Hello, everyone. In this lesson, we will learn about the programming and processing of parts of mask rolling machine. What is presented in front of us is a simple mask rolling machine composed of a bottom plate, cover plate, left and right vertical plates, tooth roller, and knife roller. The gear drives the tooth roller and the knife roller to rotate. In the real mask production line, the tooth roller presses outlines on the mask cloth, and then the individual mask will be cut and separated by the knife roller. In this lesson, we choose the left vertical plate as the processing object. The left vertical plate supports the shaft roller for movement, so the processing of the left vertical plate needs to meet the high shape and positional accuracy requirements. There are more contours to be processed, and the process is relatively complex. Let's learn about the front machining of the left vertical plate. The key to front machining is to ensure the size and positional accuracy of the bearing hole. Meanwhile, some of the grooves have the same high requirements for dimensional accuracy, with an accuracy of about 0.03 millimeters. Our main objective in this lesson is to learn about rough machining of the front of the left vertical plate. The machining equipment used is a CNC 3-axis milling machine. Workpieces are clamped using a vise, with padding placed at the bottom. During actual operation, use a sintering rod to touch the four sides and upper surface of the raw material to establish the machining coordinate system. The workpiece material is 45 steel, high-quality carbon structural steel with moderate hardness for ease of cutting. Tool selection: based on size measurements, use a D10 end mill for roughing, a D8 end mill for secondary roughing, and a D6 end mill for tertiary roughing. In this lesson, we focus primarily on rough machining and understanding its process characteristics. Large feed speed, large cutting amount, large cutting force, and large heat. Rough machining and finish machining shall be separated, which can effectively avoid workpiece deformation. Rough machining generally does not require high surface quality. Then we propose to adopt the following process. 1. Overall roughing. 2. Second roughing. 3. Third roughing. The toolpath strategy is as follows. 1. Overall roughing. Machining method. Cavity mill. Cutting mode. Follow the periphery. 2. Second roughing. Machining method. Cavity mill. Cutting mode. Follow the periphery. Spatial range, reference tool, key points of cavity mill. Primarily used for rough machining, it is the most frequently used machining method. It quickly removes excess material from the blank by specifying part and blank. Second and third roughing can be performed by specifying spatial range. Let's open the UG software and complete the creation of the toolpath for the front rough machining of the left vertical plate. For this part, the first thing to process is the mounting surface of the bearing hole. At first, you need to set the coordinate system in the center of the workpiece. The setting of workpiece refers to specifying the part as the material object, specifying the blank block, and select the inclusion block. Set the margin Click OK. Click OK. At this time, start processing. The first step is to rough mill the surface of the blank. Create a tool with a large diameter. Select the plane processing. Specify the base. And then generate a tool path. Next, use the cavity milling to perform the rough machining. At first, create a milling cutter with a diameter of 10 millimeters. Select Cavity Milling. Then click OK. Then specify the cutting depth and cut directly to a depth of 18 millimeters. In other words, the cutting depth shall be just larger than the depth of the bearing hole. Click OK. Set the relevant parameters and the transfer option to Previous Plane. We found that some narrow areas are hard to cut, so we need to use some small diameter tools for the second roughing. Create a milling cutter with a diameter of 8 millimeters, copy the process, and click the cutting parameters. (4) Spatial range. We select the tool with a diameter of 10 millimeters as a reference. Then click OK. Please answer the following questions.